Today we're going to focus on multiplying rational numbers. And when you're multiplying rational numbers, you use the same rules that you used when you were multiplying integers. So that first rule was that if you're multiplying two rational numbers and they have the same sign, they're both positive or they're both negative, you're going to end up with a positive answer. The second rule says that if you're multiplying two rational numbers and they have different signs, so one is positive and one is negative, your answer will be negative. So here we have two rational numbers that are fractions. 3/4 times -8/9. Whenever we see a problem that doesn't appear to have an operation symbol, we're multiplying those two things. I know this is not subtraction because the parentheses around the -8/9 tell me that that is a negative sign that goes with that fraction. So 3/4 times -8/9. I'm going to assign my negative to my numerator so that I don't forget about it. When I'm multiplying, I can also cross reduce. This helps us avoid having to reduce so much at the end of our problem. So I look across and I see that 3 and 9 are both divisible by 3. So I can divide them by 3, and here I get 1. 3 divided by 3 is 1. 9 divided by 3 is 3. I can replace those with my new reduced numbers. And going across the other direction, 4 and -8 are both divisible by 4. 4 divided by 4 can be replaced with 1, and -8 divided by 4 can be replaced with -2. So now I can multiply across. 1 times -2 is -2, and along the bottom 1 times 3 is 3. So we have our final answer of -2/3. Let's try another one here together. This one has mixed numbers, so the first thing we're going to have to do is change them to improper fractions. So this will become -10/3. And this guy will become -27/10. And I'm putting my negatives up there with my numerator so I don't forget about them. I can do a bit of cross reducing here. The -10 and 10 are both divisible by 10. So 10 divided by 10, I'm going to replace this with a 1. -10 divided by 10, I'm going to replace this with a -1. 3 and -27 are divisible by 3, so I'm going to replace this guy with a 1. 3 divided by 3 is 1, and -27 divided by 3, I'm going to replace this with -9. So along the top here, I've got -1 times -9, which gives us +9. And on the bottom, I've got 1 times 1, which is 1. And this guy can be rewritten as a mixed number. Actually, it's going to just be 9. It's going to go right to an integer because there's nothing left over. So +9 is my answer. Here I've got some decimal problems. So when I'm multiplying my decimals, I'm multiplying here -2 and 5/10 and 3 and 6/10. I'm just going to line them up. I'm only going to worry about their absolute values when I'm first multiplying them. So I'm going to do 2.5 times 3.6. Don't worry about the decimals right now. So 3 times 5 gave me 30, carried my 3. 6 times 2 is 12, plus 3 was 15. When I go to start my second line, I'm going to start with a 0 as a placeholder. 3 times 5 is 15, I carried that 1, and 3 times 2 plus 1 is 7. When I add these up, I got 900. So to decide where the decimal is going, I have to see in my problem how many numbers were behind decimals. So in my factors, I had 2 numbers behind decimals, and so when I went to my answer, I moved the decimal over 1, 2 spots. My final answer here is -9 because I was multiplying one negative and one positive number. So -9 is my final answer. All right, let's try this one together. So first I'm just going to multiply their absolute values. I'm going to put 5 and 22/100ths on top because I like putting my bigger one on top here, my longer one, times 1.8. Something that's a little bit different about multiplying decimals, I don't have to worry about lining up the decimals. So I'm going to write it just like this. I'm going to pretend like the decimals aren't even there right now. 8 times 2 is 16. 8 times 2 plus 1 is 17. 8 times 5 plus 1 is 41. I'll start my next line with a placeholder of 0. 1 times 2 is 2. 1 times 2 is 2. 1 times 5 is 5. And I'll add all this up. Now to decide where the decimal goes in my answer, I'm going to go back to the original problem. I had 3 numbers in my factors that were behind decimals. So the decimal here is going to move 1, 2, 3 spots over. Since I was multiplying 2 negative numbers here, they have the same sign. My final answer is going to be positive 9 396 thousandths. In this next problem, we have an exponent. They're asking us to multiply negative 1 2/3 to the third power. I know the negative goes with my 1 2/3 because there's parentheses around them. They're 1 unit. So it's really asking me to multiply negative 1 2/3 times negative 1 2/3 times negative 1 2/3. So I'm just going to start with the first two. Negative 1 2/3 can be written as negative 5/3. So I'm doing negative 5/3 times negative 5/3, which gives me positive 25/9. So I've multiplied 2 of them. Now I'm going to multiply by the third negative 1 2/3, converting it to negative 5/3. And 25 times negative 5 on top gives me negative 125. And 9 times 3 is 27. So I have a final answer of negative 125 over 27, but this guy is not in simplest form. 27 goes into 125 4 times with 17 leftovers. So my final answer is negative 4 17/27. So this guy we're going to do together. We're going to start with the problem that's inside the absolute value here. So I've got 4/5 times negative 7. To turn this negative 7 into a fraction, I'm going to put a 1 under it. So 4 times negative 7 is negative 28. 5 times 1 is 5. And since I'm trying to find the absolute value of this problem, my final answer is going to be 28/5. I have to remember to multiply by this negative 1/7 that I had up here. So I have a little bit of cross reducing I can do in this one. 7 and 28 will both divide by 7. So now I've got across the top here negative 1 times 4, and I get negative 4. And on the bottom, 1 times 5 is 5. So our final answer is negative 4/5.